Okay, so we have this question here. Let's just remove all of this. Let's put in this right here. Put in some doc strings. Lovely. Yeah, a bit ugly to be honest. I'll just organize it. Oh, maybe I won't get it organized like this, to be honest. Let me just, yeah. Okay, I feel like this is a fair kind of point to start. And I'll just kind of close that. It's LRU Cache. This is a linked list question, so again, a little bit of a hint. But I'm going to try and forget about that and just kind of follow the structure that I've been doing for these technical interviews. So design is data structure that follows the constraints of a least recently used LRU cache. Implement the LRU cache class. LRU cache in capacity. Initialize the LRU cache with positive size capacity. Int get int key. Return the value of the key if the key exists. Otherwise -1. Void put in key and value. Oh, honestly, I remember like Uber didn't they didn't even give me this. Like I had to like work my way to try and guess that as well, as like edge cases and all that. So, but void put int key and value. Update the value of the key if the key exists. Otherwise, add the key value pair to the cache if the number of keys exceed and the capacity from this operation. Evict the least recently used key. Functions get input must each run an O1 average time complexity. Oh jeez, that is, well, even this, I would not get this. I would have to like ask my way to it. So a lot of information here that was given for free. Very lucky, but I shouldn't take that for granted in an actual interview test. Like if I were to give this question to like a fellow friend, I would really challenge them. And like I would like they didn't like even give me the parameters. Like I had to make my way and try to understand what the parameters were, which again, it just takes more time. So first off, before I even like go on and do an example, I'm just gonna like do the like boilerplate stuff. So like, you know, define this LRU cache. You know, so we have this method called get. What are its parameters? That would be a question for the interviewer. What's this return type? Okay. You know, what happens if we don't have like if we get something, it's not actually in, like it doesn't exist. Like what happens? Like that would be a -1. So like just like return -1 if key doesn't exist. Right, just a note to make because I think like I forgot to do this -1 case in my situation. And then def put key int. Oh, I made this mistake as well. Self isn't a thing you do in Swift. Like that's the programming language I use the most. I keep on forgetting this in Python. Another thing to consider is whether or not I'll need like a init. This is something else I messed up on, but this is where you kind of set up your property methods if you have any. So I'll just kind of add it over there as well. Key, and then what else? What other parameters are there? There's a value as well. It returns nothing, so we'll just leave it at that. So we put something, and if the number of key, if the numbers, like we have to remove if the number of keys exceed. Evict the least recently used. If number of keys exceeds capacity. Well, hold on, where's capacity's node? Hold on. And it, oh, okay, so initialize. I forgot to read that. Initialize the LRU cache with a positive size capacity. Cool. Positive means, does that include 0? Lots of good questions to ask. It's getting warm in this room, oh my. Okay, sorry, got sidetracked there. Self.capacity. is equal to capacity, and then add that as a parameter here, capacity. Alrighty. Okay, so I think that's a good amount of boilerplate code. LRU cache and capacity. Initialize the LRU cache of positive size capacity. Return the value of the key if it exists, otherwise -1. So if this has to be O of 1 and this is a get, that implies it's some kind of a dictionary. Like a dictionary needs to be leveraged. But wait, hold on, this is a linked list question, so maybe I should consider that too. And then update the value of the key if the key exists. Oh, if the key exists. Oh, interesting. What happens if the key doesn't exist? Just don't update. Need to check if key exists. I guess that's another assumption I made. Yeah, so lots of clarifying questions to ask. Yeah, so dictionary is what it implies. Linked list can't give you, like if it's in the middle of the linked list, it can't give you the key in O at time. Update value if the key exists. So you need some kind of a dictionary to keep track of where, like keep track of the nodes, I'm assuming. And otherwise add the key value pair to the cache. If a number of keys exceeds the capacity from this operation, affect the least recently used key. The least recently used key, what does that mean? Like if I guess before even like, I keep on making this mistake of like trying to clarify this problem before even doing an example. So imagine we had capacity, I don't know, like 10. Okay. We had design a data structure that follows the constraints of a least recently used cache. So like for now we'll like use a list, for example. Okay. We get return -1 if the key doesn't exist, so it doesn't matter. Hold on. Otherwise add the key value to the cache. I see. Never mind. So key value pair both are integers. Okay, so 1 and 1. Or maybe I'll do like 2 or something. I don't know. 1 and 1. Put 4 and 1. Okay. I just keep on doing that, and then if the key exists, then what happens? Update the value of the key. If the key exists, then we update. Like if we do 1 and 3, then we do 3, and we just keep on doing this. Maybe like 5 and 10. Maybe like -1 and -300. I don't know, and then just like copy this. Change the values. 2, 17, 15, 10, and then we'll just do like a 8, and we'll do a 9, and then we'll do another one, 11. But the problem is, I think this is the value that's 11, right? Because 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So least recently used value, is that this? Or is least recently, so basically, do you know how I like, So I like updated this. It was like a 2 before, and then it was 3. So when I updated it to a 3, then I have to like move this like over here or something. Right, and now the least recently value, it's like it's almost like a queue. You gotta like first in, first out. But then wait, so why is this a linked list? Is it because because when we remove it from here, we can technically add it to the end over here. Oh, but if we remove from here now, right? If we remove from here now, how does this kind of value know that we should point to there, and how does this value point back to this? That's why it's a double linked list. I think it'd be a double linked list. Or maybe I'm wrong, I don't know. Yeah, good things to consider. Alright, and then, so remove this. So that's the thing, remove this. And now we're at this. So that's like the example I'm kind of going through. Put get. Oh yeah, don't look at the constraints yet. We're at 11 minutes. I'm kind of already brainstorming the solution. I'm kind of doing this, I'm doing this as a human. I'm going through this kind of example as a human, kind of noticing things. And I'm noticing a list won't work because if you have to remove it from here, that's O of n. Well, like it will work, but it'll just be a greater time complexity, and we want O of 1, right? If we want to put, like, remove from here and add to there. So, you can, from the very beginning, you can remove. That's first in, first out, so that's a queue, almost, and linked lists have that capability. And then there's a stack kind of feature as well, but then there's also this feature where you kind of have to do it from the middle. And that's where the linked list kind of can really shine, because then you have like a pointer, the previous pointer, and you have a next pointer. If you remove from here, right? Like imagine you update this to 11. Right now, if this is a linked list, this points to this points to that. But now, this knows to point to this new value, but how does this value know the previous value? Right, that's why you need like a double linked list. And if you keep a reference to it, right, and that would be through some kind of a dictionary, then you can make it work. So dictionary, keep track of threes, like keep track of the key, and then keep track of like the node. I don't know, what would you call this node? Almost like a dictionary in and of itself. Yeah, it's a bit of an odd kind of creature. And so, in that sense, return the value of the key. So 1. Then you have the value, and you have a node. So like a kind of like it's a bit of a weird structure, but like, so value being 3 and like node 1 3. Right, and then you just kind of continue that on for the rest of the dictionary. because then you have a reference to this dictionary, this node. You have a reference to previous, a reference to the next, and you can like kind of connect them together. Cool. So again, this would be O1. If it exists. This would be O1 as well. But this, oh no, oh yeah, I guess I didn't really have anything else to add. Cool. Cool, cool, cool. So what I'll do is I'll start off with a double linked list implementation. Okay, and I'll start off with the definition of init self value. We'll do a default value that. Next, actually, we'll do first none, and previous we'll do none as well. And then we'll just like set self dot value is equal to val, self dot next is equal to next, and self dot previous is equal to previous. I think that might give us a problem, so let me actually just do this. Yeah, I don't know why it was glowing. Maybe next is like a keyword or something. So I'll do that. And then here I'll do self dot like q almost. Self dot q. And I'll do like a double linked list implementation. And then here I'll also do self dot dictionary with node reference. Don't really like that explanation, but it should be okay. Yeah, I think that should be better. So we have all this. Now we know we can do self dot dictionary with node reference, or like how can I name this a bit more easily, like a bit better? Key to value and node. D. Self.d. Sure, why not? I know what that means. Self.d and key. So I don't want this to I think this is going to create a dictionary. If key not in self dot d, I don't know if that's like linear time complexity check, return -1. Otherwise return self dot d key. So they here put if key not in self.d, we do self.d, and then we've got to do a capacity check as well. If self dot check length of self.d, like self.d is equal to is greater than capacity. Then we gotta do something here. Like run LRU to remove self.d value. I mean, whether or not it's actually in here. Yeah, in both cases, we need to just like run this. And then this algorithm here so, and I just have to remind myself that it's gonna be of this structure. The key value node, okay? Self.d key, self if key. There's so many selfs, man. Not in self.d. Self.d key is equal to the empty array. Dot append value. And self.d key node linked double linked list. Key value. Key dot append node. Node dot next. Node dot next, none, but node dot previous is important. You want to keep a reference to the end of the list too, don't you? Self.end of Q. Currently it should be Q. End of Q. This is, oh my. Why is this so hard? Oh my god. End of Q. It's a self.end of Q. End of Q dot next is equal to node. And then end of Q is equal to node. I think that should do it. That was a lot of pointers to point. So we have a node, add it to node. The previous we have to add to self.that. End of Q dot next we have to add to node, and end of Q we have to change to node. and then run LRU algorithm. Well, again, hold on. Like, what am I doing? What am I doing? Do I need a linked list to even solve this? Do I even, like, is this double linked list? Like, I think I'm, like, I'm saying, what happens if you, like, delete from here? Oh, yeah, never mind. Yeah, 511. You could edit from there. Doesn't necessarily have to be. Yeah, if you edit it from the middle, you can, like, put it over there. Which is what I think, what is happening here. So here we have node. So hold on, this also doesn't guarantee that it's gonna keep it as 2. Because this is specific to this code. Else, so we have a node. Hold on, I'm doing this too much in my brain. So we have a node, right? A new node. We have this existing like linked list, right? And it's pointing backwards, front, and then we set up this new node. We add it. To the dictionary. Okay, cool. Then know that previous is equal to this. Okay. And then end of queue. Like, so this is end of queue. Okay, end of queue. And then this end of queue. Next, we point to this node. So we kind of add an arrow there. I hope that makes sense. So arrow there and arrow there. So the arrow has been done. Then the last line is we change the end of queue to be this, from there to there. There we go, yeah. So that completes that steps. And then in the else case, first of all, we gotta find the reference. So we have to find run removal algorithm self.d.key 1 node to update, right? Because like I mentioned, it can be in the middle, like it could be like this one right here that we want to edit. If you want to take this node, we already have a reference to it, so let's change the pointers. So this, we want to change it to there. So node to update previous is equal to node. Hold on. Previous dot next is equal to node to update dot next. then we want to point it back. So node to update.next.previous is equal to node to update.previous. Okay, so we've enabled the pointers from there, so we've gotten rid of this. Gotten rid of that, and we've gotten rid of this. Okay, now we got to deal with this node and where it points next, where it points left. So node to maybe I should delete this. So node to update dot previous is equal to end of queue, right? So let's just move this over here. So node to previous, and you want to point the end of queue next to here as well. So end of queue next is equal to node to update. I know there's like duplicate code, but this makes more sense to me, so I'm just gonna keep it like that. And then you wanna, of course, update end of queue to end of node like that. So there, and end of queue. I've noticed my oh yeah, it's capital here. It's just not capital here. Whatever. Okay, that picture helps a lot. That's good. And then we want to run the removal algorithm. This is just removing from the front. So we're not popping, but we're taking the queue, self.queue, just removing the first element from there. Self.queue is equal to self.queue.next. Could capacity be 0? It's 1, okay. I think, like, unless I'm missing, like, cases or whatnot, this should be okay. But let's see. Syntax errors. LRU Cache. LRU Cache. Do I need to make test cases too? All of these, I don't need to put in the parameters, right? Because it only accepts this to new. That's weird. Can I make my own test cases in LeetCode? I don't know. Okay, so what's the error? LRU Cache. LRU Cache takes no arguments. What do you mean it takes no arguments? It takes an argument right here. What in the world? Can you explain where my code I'm wrong? Line, I don't even have line. Yeah, there's probably some other like. What's going on? Okay, what am I doing wrong? LRU Cache. If I call LRU Cache 2 object, right? And I say object dot get, I don't know, 1. That should give me -1. Okay, and then if I do object.push 1 and 2, that should give me nothing, but it should at least. Does it give me at least a console? No. Okay, hold on. Bro, I'm passing in something right here. It's capacity. What do you mean LRU cache takes no arguments? How are you supposed to define the capacity then? It follows like, the constraints of the least recently used LRU cache. Implement the LRU class. Oh, I also didn't mention the time complexity, didn't I? So time complexity, I mean, O1 was what we were aiming for, and space complexity is O of n, n being the number of keys values, those pairs basically. We have like 2 or 3. Yeah, we have like 3, 2, like the dictionary, and then the linked list, like 2 O of n's, but they just end up being like, if you kind of asymptotically, they're just like O of n time complexity. What am I doing wrong? So I'm just gonna submit this so my work is not deleted. Okay, and then run. Your cache object has no attribute D. What do you mean it doesn't? It does right there. Do I need to define it in the dictionary? Sorry, in the here. Bro. Hold on. I'm gonna be searching up some Python class information. Python class is 38 minutes. Python class and objects. Yeah, you can have a property outside of the init. The self parameter is a reference to itself. Interesting. So, because what I'm thinking is I need to like do end of queue and all that, but like that's, I don't know, that feels weird. There should be a way to avoid that. I want, okay, ChatGPT it is. I want to define property variables in my class. Don't want to pass them into the init as parameters. Is that possible? Okay. Hold on, let me restart this. Confirm. So what is this? Why is capacity allowed here? name is a parameter. Age, you don't. Yeah, you can do that too. Like you can pass some parameters and some parameters you don't need to pass. So let me start from. Oh my god, hold on. Capacity, key value. LRU cache takes no argument. Oh my god. What is this? My class says. Okay, I'm gonna leave it at this. I'm gonna leave it at this. I'm gonna watch the video. I think there should be a neat code video for this, and see what I'm doing wrong. All right. Think.